Recording terhenti lah tadi. Alamak, spoil betul lah. Never mind lah. Tak apalah. We continue our lesson. We continue our lesson. Hold on. Why the screen has stopped? Spoil. This one kot. Let's see. Yeah, this one. It's recording. Alah, ni terbunti lah. This one. Hey. Kat mana tadi? Alright. Now look at the equations. Look at the equations. Again, step 2. We move back to step 2. Recognize this is a Gaussian integral. The general form is integral of e to the minus beta x squared dx equals to square root of phi over beta. And here beta equals to over a squared. Beta equals 2 over a squared. Sekejap, kita tengok dulu. Alright. It's a combination of this one and also this one. It's a combination of the first part and also the second part over here. Right. But bear in mind, I won't ask you this question in any test or any final examinations because I won't ask you to derive. Okay, these are the calculations being done behind the screen by the computer. I won't ask you this one. So, step 3. Step 3, substitute. We get c squared times a times square root of pi over 2 equals 1. This is step 3. So step 4, solve for c. And c, you'll find that c equals to 2 to the 1/4 power times pi to the minus 1/4 power times to the minus 1/2. Ni. Kat sini. Ni, saya sebut yang ni. This one. Okay, so after we have done after the computer has calculated these equations behind the screen, this looks complicated, but the key physics is that c scales as 1 over square root of a. Right? So why do Gaussians need smaller amplitudes to keep the total probability normalized to 1? So Gaussian packets are extremely important because they minimize the uncertainty principle. They are the most localized states possible, right? So certain calculations, certain simulations is being done behind the screen by the computer just to calculate the probability density of electron to exist. So these are the steps that has been done by the computer. These are the equations, right? Now we look at this interactive simulation, particle in a box. Now we have a custom interactive simulation that brings everything together. Look at the simulation on the left-hand side. Okay, the one looks like swinging rope kan, macam tu kan. You see the infinite square well with walls marked V equals infinity. V means potential. So inside, there's a blue wave function oscillating. Dalam infinite potential well, there's a blue wave oscillating. So this is the quantum particle confined to a box. Electron in a box. Imagine electron in a box, particle in a box with infinite square well. Now start with quantum number n equals 1 using the slider on the top. Okay, the slider n equals to 1. We have set this one 1. See, this 5, 4, 3, 2, 1. This quantum number 1. Let me answer my phone for a while. Okay, we continue. N equals to 1. What we are simulating right now, this is the ground state of electron. Ground state means when the electron hasn't absorbed any energy from the sunlight or any heat energy from the outer side, right? The electron stays at the ground state, relaxing. N equals to 1. The quantum state equals to, quantum number equals to 1. So have a sine wave with no nodes inside. This is have a sine wave, the oscillating wave function, the blue wave function that you are looking right now is a half sine wave, because sinusoidal should be like this. So you are saying only half of sine wave with no nodes inside. So the wave gently rises and falls, oscillating indefinitely. So now watch the energy level diagram on the right hand side. On your right hand side, there is a slider, and okay, watch the energy level diagram. Sorry, not the slider, before the slider. There's a energy level diagram on the right hand side, dekat sebelah kanan tu. Kan, energy level, saya tulis energy level kat situ tu. Kan? Right. So the N equals 1 level is highlighted in teal. Dalam bentuk biru teal tu. Kan? So click the play button. Try to click the play button and watch the wave oscillates in time with cosine of omega t. Ish, tak keluar pula ni. Ni dia. Try to click play button. Okay, so it's oscillating, right? Tadi sepatutnya tak oscillating lah. Now click, if you click it, it is oscillating, right? Okay. So now increase N. This is ground state. How about if try to increase N equals to 2 using the slider? Okay. So we stop it for a while. Increase the quantum number equals to 2. Okay, now we play. See? This is N equals to 1. This is N equals to 2. See what is happening. Jadi lain kan? Alright. So, immediately you see a node appear in the middle. Ada node dekat middle tu. There's a node. A point where psi is 0, which means the probability is 0. This one. This one. There is a point that the probability is 0. Part yang merah tu kan? The red one. The red dots. Oh, lagging lah. Lagging. Tak keluar pusing-pusing. Dekat saya punya ni dia keluar dah pusing-pusing ni. Kenapa tak keluar? Simulation, but you can use your own slide lah. Right, to click it. Right. Cuba main-main dulu. Try. Tengok dia ada pusing-pusing tak? Right. So the particle will never be found at the exact center of the box. There will be no electron can be found at the center of the box if N equals to 2. Now look at the energy diagram. Energy diagram. E2 is 4 times E1. Ada keluar tak? Alamak, tak ada keluar lah. Why? It doesn't show. Kat sini tak ada tulis lah. It doesn't show anything. Oh man. Oh, ada. Sorry. Tapi the value doesn't show us. It doesn't show the value. Let me try. Alah, tak nampak lah. Tak nampak. Tak apalah. Dia cuma tulis sini. Ya. Is N1. Okay, N1 is over here. Yeah. Sorry. Yeah, it's showing. The position of N equals to 1. Oh. Stay in the cell. Alah, you tak nampak lah. This simulation is actually moving. This one actually is moving tau. Why? But you can click your own slides. If you click your own slide, you could see that the simulation is functioning. Kan? So this is N equals to 1. The energy level is over here. The energy level is over here. So if we increase the quantum number N equals to 2, see, the energy level has increased. N equals to 2 over here. Somewhere over here, the energy level. So so energy increases as N squared. Okay, N squared increases, the energy increases. So increase to N squared 3. Now, there are two nodes. The wave has 3 lobes. E3 is 9 times E1. Keep going to N equals to 4 and 5. Now, count the nodes. It's always N minus 1. The nodes, cuba tengok. Bilangan node tu mesti N equals to 1. N equals to 1, N minus 1. For example, N equals to 1. The number of nodes, 0. Because our N is 1, 1 minus 1 equals to 0. How about N equals to 2? N equals to 2, the number of node is 2 minus 1. So number of node is 1. See? How about if N equals to 3? N equals to 3. 3 minus 1. Our nodes is 2. Let me try to stop. See, the nodes. Titik yang tak ada probability ni. Pak. 1, 2. Pak. Nodes. The place where the probability of electron to exist is 0. There are 2 places. Kat situ. Kalau kita increase N equals to 4, so the number of nodes will be 3. Sebab 4 tolak 1. So 4, see? 1, 2, 3. 3 nodes. So on and so forth. So this is how the simulation works. Even though I don't ask you to calculate, to memorize the wave function, the derivation of psi square, but you must know this. What is the connection between the quantum number? Okay, the box width. You can play around with the box width. The box width over here. The box width. Let's say the box width now, from x equals to 0, x equals to 50 nanometer. If we increase the box width 60, 70, 80, 90, could be until few thousand nanometer. So what will happen with that? What will happen with that? Tengok apa perkembangan jadi. The nodes still maintain the nodes. Kan, nodes takkan berubah. Dia cuma berubah tu punya wavelength becomes stretched. So if we change the quantum number, we will change the locations of nodes in our wave function. N equals to 2, we have 1 node. N equals to 3, we have 2 nodes. N equals to 4, we have 3 nodes, so on and so forth. So this is the wave function. How about probability density? Always positive. Probability density always positive. See? Remember, wave function, psi, we have sinusoidal, we have peak, we have trough, we have positive, we have negative. But if you choose probability density, it's a psi square. When we have psi square, everything is squared, so we don't have any negative. We have positive. See how it transforms. Look carefully how we transform. This is very important. I might ask you to draw the wave function in infinite well with quantum number equals to 4 or 3 2, and 1. So if quantum number is n equals to 4, make sure the nodes are 3. Macam ni. So if you are drawing wave function, should be like this. You have positive and negative. And if you are drawing the probability density, it should be like this. Instead of 1, 2 peak and 2 trough, you should be able to draw 4 peaks, because all must be positive. Or I might ask you to draw both like this. Draw both wave function and probability density coincide together using pencil and pen, or using solid lines and dotted lines. Maybe I could ask you something like this. And you must be able to see the energy level is changing with different quantum number. This is ground state, n equals to 1. This is first excited state, n equals to 2. Second excited state, n equals to 3. The third excited state, n equals to 4, so on and so forth. So the energy level is increasing with certain difference between the energy. So what is the difference? The difference is, I did mention just now. Let me rephrase it one more time. The energy. So look again at the energy diagram. E2 is 4 times E1. E2 adalah ini. This is E1. E1 kat sini. How about E2, the energy level? Electron with excited state, the first excited state, it becomes like this. So E2 is like this. Naik atas sikit. Tapi berapa banyak, berapa kali ganda? E2 is 4 times E1. If E1 is 12, so E2 should be 12 times 4, 48. How about E3? E3 means if n is equals to 3, this is our E3, the energy of electron with excited state. Number 2, the energy level is how many times? E3 is 9 times. Ingat gini je. E1, E equals to 1, En, if n equals to 1, E1, it has certain energy level. So E2 is, the energy level should be to the power of 2. Square. So it's 4 times. How about if the energy level for E3, square of 3, 9 times. How about E4, square of 4, means 4 kali 4, 16 times bigger than E1. Itu maksud dia. Nampak ni. Ni E3, E4, 16 times even bigger than the E1. E5, 25 times even bigger than the E1. E1 kat bawah tadi ni. Sekarang E5, N5 tu kat atas. Tinggi. Energy level is keep on increasing. Because when electron being excited, it means that electron is absorbing energy. So it jumps to the higher energy level of electron, of orbits. Okay. I could see something in the key inside doesn't showing correctly. For example, the lambda, something over here. I will modify it as soon as possible. Well, I think that is all for this session. So I will continue this time-dependent Schrodinger equation shortly, and I will upload the videos soon. All right. See you guys soon.